So let's just try to understand the MergeSort code in C. So as you know, MergeSort follows the divide and conquer approach, where first of all we divide the array into two halves recursively, then we sort each of the individual halves, and after that we finally merge the sorted halves back together. So here first of all we call the MergeSort function. So the MergeSort function will basically divide the array in each step. So in each step it will divide the array by half until each half has only one element left. Now after that we call the merge function. So the merge function basically sort all the halves and then merge them back together, and finally we got the output where all the elements of the array will be sorted. So let's just see the step-by-step process and try to understand the code. So let's just see how we can sort this array of elements using the MergeSort. So here we have the MergeSort function, which takes the array containing all the unsorted elements, and then we pass the low and high range of the array. So this is the low range of the array and this is the high range of the initial array. Now here we have the condition, so the recursive call will continue as long as the low range is lesser than the high range. So that means we are gonna continue to recursively call the function as long as we have more than one element in our array. So first of all we are gonna calculate the middle position of the array, and after that we are gonna call this MergeSort recursively, and we are gonna pass the low to mid. That means we are gonna pass the lower half of the division. So suppose you are calling the MergeSort with this array with this low and this high. So the MergeSort basically going to divide this into two halves, and then it will recursively call the MergeSort function for the lower half. This half will be called, so that means here we're gonna have the values 3 and 2, and then because we are recursively calling this function again, so that means, so again we are calling this MergeSort function, and this time this will be the low and this will be the high of the array. So again we're gonna calculate the middle position, and then we're gonna divide this like earlier. So this array again will be divided into 3, and because we have one element, so the recursive call will get back, and now we're gonna call this MergeSort for the upper side of the division. So that means this will be divided and we're gonna have this 2 in the upper section. So we're done with this lower half and the upper half of the array. Now we're gonna call this MergeSort function to merge these two halves. So because we are left with only single elements, now it's time to merge them back together. So here is the merge function which merges two halves together. So here we pass the array. This is the original array. So this is the low, mid and the high index. So here we are calculating the size for the left subarray. So n1 is the size of the left subarray and n2 is the size of the right subarray. And then we need some extra space, so we are creating these temporary arrays. So these are the temporary arrays which will hold the elements so that we can merge them into our original array. So we are creating the left and right temporary arrays with the size n1 and n2. So here we are copying elements from the left subarray into this temporary left array, and here we are copying elements from the right subarray into this temporary right array. Now it's time to merge them together. So we are using the index I, j and k. So we are using the while loop. Here we're gonna merge them together. So here the condition is as long as the left subarray index I is less than n1 and the right subarray index j is less than n2, we're gonna continue this while loop. So here we have the condition: if the left array value is less than equal the right array value, then we're gonna take the value from the left array and we're gonna store it into our original array in the position k. So k starts from low, so that means we're gonna store this into the low position, and then we're gonna increment the index. Otherwise, if the right subarray is lesser than the left subarray, then we're gonna take the value of this right subarray and we're gonna store it into our original array, and then we're gonna increment the index j. So that means we're gonna get the value from the left subarray when it has the lower value. Otherwise we're gonna get the value from the right subarray, and after that we're gonna increment the index k, which is the index of this original array. Now this way the copy will continue, so that lower value from both the array will be stored into our original array one by one. Now this while loop will break when either the left subarray or the right subarray values are exhausted. Now in case when the right subarray, when the right subarray values are exhausted, in that case we have to copy all the elements from the left subarray. So here we are using this while loop and we are copying all the elements from the left subarray. Now otherwise, when all the elements from the left subarray exhaust, in that case we have to copy elements from the right subarray, and one by one we are going to store them into our original array. So this way both the left and the right subarray elements will be merged into our original array. So that means here whenever we call this with the low, mid and high, so that means these two elements will be sorted and merged together. Now the function call will go back to this MergeSort. So this MergeSort will be called with the upper range of the array. So that means this upper range. So we are done with this lower range. Now here we are gonna have the values 1 and 5, and again this will be called again. So here they will be divided again. So we're gonna have 1 and the 5. So because we are left with one element, that means the loop will break, and now the merge function will be called. So the merge function will merge these two values together. So we're gonna have 1 and 5, and again the merge function will be called again, and this time these two arrays will be merged. So we're gonna have this final output 1, 2, 3 and 5. So this is the final output of the MergeSort. So this way the MergeSort function will initially divide the array into two halves in each step, and then we call this merge function. Merge function will basically merge all the halves back together. So here we have the merge function which merges two halves together, and here we have the MergeSort function which recursively calls and divides the array into two halves. Now inside the main method, suppose we have one array with the elements 3, 2, 1, 5. Now here we can call the MergeSort function and we can pass the array. The low is 0 and the high is size -1, so this will be 3. Now if we print our array, so you can see the array is sorted after applying this MergeSort. So hope you understand about this MergeSort. See you in the next one. Take care.